What I want to do is design and cut the plates or the stiffeners for the frame rails. I could do this the old-fashioned way and just take my measurements and then map it out on CAD. I use Fusion 360, but I have some, what I'm going to say is better ideas. I think it'll help a lot down here with this curve. So the first step of the process, if it works, will be take a picture, and then you can import your picture into Fusion 360. You import it, you calibrate the picture. So I don't want to go through all this work, cut out my stuff, and then it doesn't fit. Of course, I could just trim it like anyone else would do. And I'm sure I'll have to trim a little bit, but what I want to be able to do is do a test piece with cardboard. I'm going to make a little holder that goes in the torch holder with a Sharpie, a spring-loaded Sharpie. And then I can run a dry cut where it'll run the pattern without actually cutting. And then I can cut the cardboard out, put it up on there. If it fits, so I know it works right. And this is going to include the bends too. So that's actually a pretty important piece to note. Because the bend, since this isn't straight, if I map it out and the bends are right, then I know this really works pretty well. First step, find a marker. You just got this. Might as well use that. I got this. I need a small spring now. Oh, we are in business. This is one of those fishing wires for a bolt. I'm gonna chop this off. This should be the perfect amount of tension. Oh, nice. Mint. So I just realized that for my other voiceovers, I forgot to change the settings for the audio to my microphone. So anyway, if you aren't interested in this CAD part, you can skip forward to the time on the screen. But if you are curious how I made this, or if you're a beginner in Fusion 360, you could probably pick up some good tips here. I am by no means a super professional, but I have learned a lot in the time I've been using it. So yeah, here we are making the holder for the marker. First section, I did a lot of adjustments with the tolerances just to try and make sure there was enough room in between the two parts. There's that inside piece that slides in the main housing, if you will. And then we have the hole that the marker goes into, so I adjusted that a little bit. I took a wrong measurement, so I had to adjust it again. But yeah, I just wanted to make sure this part was good so that it wouldn't be too tight and it wouldn't be, too loose. So here we're just making the cap, or the start of the cap, that will be screwing on to the end. And then here's the kind of the sleeve that projects up. So off the sleeve, we create the threads with the coil tool. This is a really cool trick I learned from some YouTube video at some point, but you can make really any kind of thread with this, which is pretty crazy. But I'm doing a little triple thread, so it only spins like a third of a revolution when you tighten it, but you have the 3 threads that are actually holding it on. So it's a quick thread, but it's also pretty strong. So I made the threads, I rounded off the edges, and then combined this into one piece from the 4 pieces, the 3 threads and the cap. Next section is pretty much a reverse on the main body. So just making the little sleeve that'll stick down, and then the threads that will be on that part of the cylinder. So I just copied all the parameters for the thread from the other one, except it's on the outside. It's an external thread instead of internal now. And then this trick is pretty cool. I couldn't remember how to do it, so I had to Google it, but you can use the move function, and you can actually like offset the face at an angle, which is kind of similar to pushing and pulling, but you can bevel the face like this, which makes it really easy. And then you round off the edges. Just doing some checks here, make sure it all looks good. Combining all the threads into the main body. And now, this is a really cool tool I like to use. This section analysis, so you can see how everything lines up and your tolerances. You can see there's plenty of room everywhere. We got the 1/2 inch inside there that I need for the spring on top. So yeah, that is good. So the next step is to put it in my slicer, Bamboo Labs, and we got it printing out here. Didn't take too long. Came out pretty nice. So it's all 3D printed. I just used PLA, which if you're not familiar is like the cheapest, easiest filament to use or material to use. First thing I'm going to do is load the Sharpie in here. And the Sharpie is tapered, which is actually pretty nice. The ID of this is the ID right up here where it gets the widest. It gets a little tight, but not bad. It was a little hard to get out. We got the threaded portion here. So I designed these threads like you saw in the video with the coil technique. And I probably could have made this a little bigger. There is a little bit of play in here. It's a little play, side to side. So I could have probably just made the threads a tiny bit like wider. Load it in the main body. Oh, need the spring first. Drop the spring in. Load this part in. You can see it's got some movement here. And I wanted that because if the surface isn't flat, obviously we're not going to be marking the cardboard, which is the goal here. So then we put our cap on, it slides over that. Threads on nice and tight. I took the torch out. Not too tight. There you go. So what I'm going to do next is draw up my plate pieces for the frame rails, and then I'll get a big piece of cardboard, put it on here, run the program, cut out the profile, and make sure that it lines up, the bends are in the right location. If I have to tweak anything, I can do that before I start cutting steel. So I'm going to take a picture of this area, so from here to here. So this will be one part, and then it'll bend down under here. So it's gonna be 3 sections. Here, where the coil bucket is now, and then this back part, since I wanna do that first actually. But this is the most complex section, so I wanna try that first. All right, so here's my picture, which we call a canvas. So to get this in, you click canvas, you select it from your computer, and you select the plane you want it in. I usually just draw things in the top or side plane. Okay, so now what we can do is right click on the canvas over here and calibrate. Now we're at 0. I would say the longer you go, the better. It's going to be more accurate. So let me get 18 here. 18 inches. Enter. Here we go. I'll try and rotate this. So I got it rotated. I had to offset it a couple degrees, and then this part's pretty straightforward, just following the profile that I want to have here on the side. So just do some lines, a couple arcs, and it's pretty much good to go. There is a bend. It bends inward a little. Say it's about there. Now these have to be like hard angles because of how the bottom will be bent. So I'll show you that then. So where we left off, I was drawing this main profile off of the first canvas. So I did that. So I set up the bottom for where the bends are to follow that. And then this, I had to map out where this bend is. It bends in this canvas in here. You can see that bend. So you can see where the bend is in the outside of the unibody rail. So I'm actually not sure if this inside lines up or if this is just looks like it doesn't because of the perspective thing, but that's why we're doing the practice cut. Do convert to sheet metal, turn this into sheet metal. I put the bend in here where that slot is. That's going to get welded, and then I did a flange off of these 5 or 4 edges. So these are in the same plane. That's why there's no actual relief here, like these ones. And these are in different planes. And I left tabs about 3/4 to 1/2 inch total per flange. So I should be able to just hand bend that pretty easily. And then I'll end up just welding this to the unibody and obviously filling in the gap. So I did measure this depth, which I think was like 3¼ inches or something. Yeah, so this is pretty much the same all the way up through, and then it narrows out here. So we'll see if that is right. Besides that, I just put the holes in for the like plug welds, rosette welds. This section on the actual frame or unibody, it's like kind of concave, so I don't think I'd even be able to get any contact if I would try and weld it. I should be able to get welds on these two seams up in there, and that one obviously. What the hell's going on here? Compute failed. This is probably an error from this right here. So I figured out the computing problem is because there isn't big enough of a relief here, and I think if I would have done that top flange and then those two bottom flanges at the same time, it would have made one. Oh baby, look at that. That is interesting. I don't know why it didn't automatically add that in. Okay, we're good with that. Export DXF. Now I sped this up a lot. I just didn't want it to be too long, but had to copy the profile, the DXF, and then make a new object, and then went to manufacturing and set up the whole cut profile with this. So that makes the program the machine will run off of. Driver side is going to be reversed to flip the logo. That's the only thing that has to change with the actual profile. Now I need my USB, so I'll go grab that. Need to cut my cardboard up. This piece should do. Cap off. I like to just run my torch around the area, make sure it doesn't bind up, because it does bind up a lot. There you have it. Let's cut her out and see how it fits. So I had this nice piece of rubber I put behind the cardboard. Knew I kept that for a reason. So that worked out well. So just cut this whole thing out. Uh-oh. Might need some tape on this actually. Probably should have left the slots uncut. Got her taped up. And then I bent it and taped those so they wouldn't move too much. I could kind of handle it better. It's pretty close. Oh, I forgot this cutout here. Well, that actually might help for now. Oh, baby. Tighter than a, well, you know. I'm gonna say that's pretty mint. Pretty mint. Hope you can see that. Ow. Lines up quite well. I like it.